So let's quickly look at the second example. The second example will include integrating the value of a cos power n of x multiplied by the sine power k of x dx, where both the powers of the cos and the sine are even. So let's evaluate this example, which is integral of sine power 4 of x, right? Sine power 4 of x dx. So in this case, the power of sine is k. It's which is k, which is what? 4. And then the power of cos, which is the n, is 0. And you know 1 power 0. 1 power 0 here gives us what? 1. So in this case, it's the cos of x power 0. And it's going to give us 1. So we must apply strategy 3 that we discussed earlier on. So now that we have it over here, which is integral of sine of power 4 of x dx, what we can do is, since it's already an even, we need to rewrite it by reducing the power. So reducing the power by substituting sine power 4 of x equal to sine square of x all square. You can rewrite this one as integral of into brackets sine square of x all squared dx. So in doing this, when we were deriving the trigonometric identity from the first principle, we said that the sine square of x, I said it should be on your fingertips. The sine square of x should be equal to 1 over 2 minus 1 over 2 cos 2x. And as I told you, when you know the sine square of x, you will definitely know the cos square of x by the change of sign. So knowing this, now we need to substitute it inside. When we substitute it inside, we are going to get integral of 1 over 2 minus 1 over 2 cos 2 of x. And then don't forget that it's all power 2. It's all power 2. So in all power 2, you just simplify it by using this one, 1 over 2 minus 1 over 2 cos 2x. And then when you are done with this is another one, multiply by 1 over 2 minus 1 over 2 cos 2x. So that's it. You can expand it. Just expand it. When you expand it, at the end of the day, you are supposed to get something like integral of, into bracket, 1 over 4 minus 1 over 2 cos 2x plus 1 over 4 cos squared 2x and all dx. Remember, we expanded this and we got that. So in doing so, we need to do some substitutions over here, right? Or we need to break down something over here. Since cos squared 2x has an even power, it's also good to do another raised substitution of whatever we did here, right? But in here, this one was a sign, but the middle for the cos one is going to be positive. So in this case, we are going to do another raised substitution of cos square of x, which is equal to 1 over 2 plus 1 over 2 cos 4x. Right. So that's what you are supposed to do, because here it's 4x. Let me see. Here it's that's cos 2 has an even power, and then if you have cos square x is equal to this one, it will be cos 4x. Right. That is cos 2x plus cos 2x. So when you expand this one, you're supposed to get that. And then let's see something here. Here it's let me do it here so that you understand the reason why here is 4x. Let me write here. So now you agree with me that cos square x over here, when you expand, we are supposed to get 1 over 2 plus 1 over 2 cos 2x. And therefore, if we are having cos square 2x, it's supposed to be 1 over 2 plus 1 over 2 cos. Remember that for the x, it was 2x. Then for 2x, it's multiplied by 2. So we are going to get 4x. That's how come here became 4x. So if you are confused, don't be confused about that. So in doing that, you go and substitute it back over here. When you substitute it back, you are going to get the integral of 1 over 4 minus 1 over 2 cos 2x plus 1 over 4 into brackets 1 over 2 plus 1 over 2 cos. That's the substitution that we are doing for x. And then don't forget that they are all dx. That's the integral. They are all dx. They are all dx. So when you are done with that, the only thing left is to simplify whatever you have gotten. So this is an algebra, so you don't have to have any issue with that. So doing your simplification, the result is going to be 3 over 8, right? Minus 1 over 2 cos 2x, then plus 1 over 8 cos 4x, and then don't forget that they are all dx. So this is how you just multiply this one through by this. So 1 times 1 is 1, 4 times 2 is 8, right? This one, 4 times 2, 8, and then you are having the 8 here. When you multiply this 2, when you multiply this here, we are having the 1 over 8 over there. So when you have the 1 over 8 here, here is 1 over 4, you add them and you get 3 over 8. And don't forget that we are having 1 over 2 cos 2x is over there, and then you are done simplification. So when you are done with it, now it has become simple to integrate. So integral of 3 over 8, we are going to get 3 over 8x minus integral of 1 over 2 cos 2x, going to get 1 over 4 sine 2x. And then plus integral of cos 4x over 8, we are going to get 1 over 32 sine 4x plus c. So you can see this is as simple as that. So please, if you didn't understand anything, pause the video or restart it, pause it, and then work it out. And after that, you check your answer to the original answer. So thank you for, okay, so before I end the video for this second example, I would like to give you a trial question. So the trial question is evaluate integral of cos power 3 of x dx. Cos power 3 of x dx, right? Cos power 3 of x dx. And then when you are done with this, please solve it before you check your answer. When you are done with it, the answer that you are supposed to get is supposed to be the integral of cos power 3 of x dx is supposed to be sine of x minus 1 over 3 sine cube of x plus c. This is what you are supposed to get.